If you remember, we started to revise probability a little bit. And we start by probability mass function. We said that if our random variables are discrete, we can represent it with a function which is known as PMF, probability mass function. But this PMF has a very special properties. Maybe from undergraduate or maybe even high school probability, you remember continuous form probability functions, which we used to call them probability distribution function, PDFs. Now we are talking about PMF because most cases that we have are discrete cases. When we are revising, I will also talk about, I will show you the formulas for the continuous form, but because we are dealing with the digital world, so everything is discrete, so discrete formulations are much more important for us. Now, one of the things that we have to know is when we have the PMF, when we have the probability mass functions, we are dealing with sets of numbers. If we add all the numbers, it means that we are adding all the probabilities of one big set. If I add the probabilities, all the probabilities of one big set, what is the result? What is the addition of all the probabilities? 1. It cannot be more than 1, right? Now, it says that when we have an event, these events are disjoint. In other words, the probability of having one event happening and other event happening at the same time is 0. Assume we have a die which has number 1 to 6, and I throw a die. So I will get a number 5. What is the probability of getting number 5? 1 over 6. What is the probability of getting number 5 and number 6? 0, because both of them cannot happen at the same time. Now, regarding to that die, what is the probability of 1 over 6? What is the probability of blue 1 over 6? What is the addition of all the 6 probabilities? 1. So this is also correct. But what about the union? We remember the formula for the union. The probability of union of two events is the probability of the first one plus the probability of the second one minus the probability of the joint, intersection. But we already know that they are disjoint, so this part is 0. So the probability of their union is the addition of each of the probability. What is the probability of having 5 or 6?
1/3.
It's 2 over 6, which is 1 over 3, because it will be for 5 it's 1 over 6, for 6 it's 1 over 6, the addition is 2 over 6. And the union, the probability of union of all of these sets, which is the addition of all the probabilities, it will be 1. Now, when we are talking about PMF, because there are functions, so we can look at them from, let's say, a real analysis perspective and name these functions. The most famous type of PMF are uniform distribution, uniform PMFs, uniform random variables. Uniform random variables means that we can treat all of the regions and boundaries that we have equally. Like if we have a die, and when you throw a die, we know that the probability of having each of these events is the same. So we call it uniform. But sometimes, which is like most of the case in the reality, especially when we are dealing with a pattern, this is not the case. If we are at some point, the probability of being around that point is usually higher than the probability of not being around that point. If you study hard, the probability of you passing is higher than the probability of you failing. So it's not uniform distribution. So there exists several types of distribution. One of the distribution that we use a lot is binomial distribution. Why binomial distribution is very important, or we see them quite a lot. Do you have any idea? Because most problems that we have we can divide it in two. Yes, we can do it. No, we can't do it. Yes, in this class. No, it's not in this class. Yes, it is this emotion. No, it is not this emotion. So we can always make things binary. And we know that by using the definition of the tree, we can make, using this binary decision, to have multi-classes. So binomial distribution is very important. We can use this type of modeling for so many problems. That's why, if you remember, I said that, for instance, in emotion recognition, people divide into two classes, positive and negative, because it will be easier for them to handle. Why easier to handle? Mathematicians for the last 200 years, they have described this type of probability and modeling a lot. So we know everything about this model. So if some events have this model, so you can always predict what should be its mean, what should be the standard deviation, what do we expect to see after several times of iterating it. Now, as I said, for uniform random variable or uniform PMF, we have a distribution like this. This is for a die. And the addition of all the values will be 1. Do you remember what was a random variable? Random variable was a function which was assigning, which was mapping our event to a number. Why did we want to map an event to a number? Because we have math, and math is dealing with the numbers. So it's very good for us to do it. So assume a die. We have a die, we have a cube, which has 6 surfaces. So what a random variable does, map each of these surfaces, let's say, to a number. Accidentally, this number is the number that we were assigning onto each surface. So our random variables are 1, 2, 3, 4, 5, 6. Well, we have to read it in this form. When x is equal to 6, it means that you threw your die and you see number 6 is appear on the die. Assume I have a coin. Assume that I have a coin. And we know that for a coin, we have head and tail. Now, if I want to say that head and tail are random variables and there are x, can you tell me that what are the values of x? 0, 1, 1 and 2. 1 and 2. What is 1? What is 2? 1 is, for example, head. 2 is, for example, tail. So then I can say that P of x is equal to 1 is equal to 1 over 2. P of x is equal to 2 is 1 over 2. So you see, I cannot add the head and tail, but I can manipulate the numbers. So this is the whole idea of this random variables. Now, then discrete random variables are kind of coming from an approximations that we have from the continuous form. So it is always good for us to know how the continuous form deals. The reason is that nowadays we can have lots of samples. We can have the number of samples that much a lot, which is actually, when we draw them, we see them quite continuous, right? So it's good to know how we are dealing with the continuous forms. When we have a continuous random variable, the PMF, probability mass function, we will change it to probability density function, or PDF. PDF is something like that. Can you tell me that what is this maximum number that we see? What can it be, or what it cannot be, or what can we say about this value? Can you tell me that what very important property should be always satisfied here?
It's between 1 and 0.
What is between 1 and 0?
The value at 80 points.
Why it should be between 1 and 0?
It should be a probability.
No, the probability dense function PDF will help us to calculate the probability. How it helps us to calculate the probability is in this form. If you want to see what is the probability of a variable x, you simply go and calculate the integral. If I want to know what is the probability of x between a and b, it's the integral from a to b of fx dx. So the area underneath this curve will tell you what is the probability between two variables. So if this is a and this is b, this area will tell you what is the probability x is between a and b. So what is the probability from minus infinity to plus infinity? It means the addition of all probabilities. What is the addition of all probabilities? 1. That's why that we have the integral from minus infinity to plus infinity. The value of the probability, the integral is 1. Now, one question. At this point, can you tell me that what is the probability at x is equal to alpha?
0.
Why?
It's continuous. The function is continuous, so one point approaches infinity. A single point approaches infinity. So for the
single point goes to infinity. Why the probability at this point kept? Why the probability at one single point is 0? I will tell you the answer. Look, at this point, 1 point, x is equal to, from x between 0 and 1, the probability is integral from 0 to 1 of fx dx. Yeah. What is the probability of x is equal to 1?
Probability.
People shout it's 0. Why is it 0? In other words, Kev, tell me what is probability of x is equal to a?
It's
Bible?
Equals a equals to b, so integral from a.
This is 0, yes, because it is an integral from one point to another point of fx dx. So integral, if we start from one point and we finish to that point, it is always 0. The area under this one point is 0. So when we have a continuous variable, when we have a continuous function, we have to look at the boundary, a region. Whereas in a discrete, we just look at one value and we say that what is the value of probability. Now, PDF will help us in order to calculate the probabilities because we usually have good information about what is this area. How do we know what is the integral, what is the result of integral? We hate integral. There are a few things. Mathematicians have calculated for us. We have tables. We can look at the table to find out what is the value. Or we can approximate it with the discrete form. So computer can write a code that computer can calculate the summation for us. So I'm not expecting you to calculate any integral at any point. I may ask questions, but you are responsible for that one. Now, another important thing when we are talking about the probability mass function or probability dense function is talking about the cumulative distribution function. What is the word cumulative means? Yes, it means additive. We have to sum it up. We have to find total at some point. So the cumulative distribution function is defined in this form. We usually show lowercase for probability distribution and capital F for cumulative one. And it says that fxv is the probability of all the random variables which are less than or equal to v. In other words, if you write f is 5, it is probability of all the values which are less than 5. So in here, in case of coin, Eric, can you tell me that what is fx2? 2.5. 0.5. Fatima, what is fx2 for this case? It means the probability x is less than or equal to 2. So what are the chances if x is less than or equal to 2? It can be 1 or 2. So it means it is equal to probability of x is equal to 1 plus probability of x is equal to 2. What is the probability of x is equal to 1? What is the probability of x is equal to 1?
What is the probability?
X is equal to 1?
What is the number?
1 over 2.
Yeah.
What is the probability of Eric? X is equal to 2? 0.5. So 1.5, 0.5 plus 0.5 it is 1. So, Abdulaziz, for the same question, can you tell me that what is the probability that x is less than or equal to 5? Or what is f of x of 5?
It's still 1.
It is still 1 because we cannot go above 1. Fatima, can you tell me that what is fx of 0 here? For this example, what is the cumulative distribution function for x? It's 0 because it means this is the probability of x to be less than or equal to 0. We know that x is 1 or 2. Less than that is impossible. And what is the probability of impossible? 0. Now, cumulative distribution function is useful in the sense that sometimes we have cumulative distribution function or we have the cumulative mass function. And we want to derive the probability dense function or the probability mass function out of it. In order to do it in the continuous form, we find the derivative. The derivative of cumulative dense function is the PDF. What do you think about the discrete form? Look, the formula is this. Fx is d capital Fx of x over dx. In other words, if I find the derivative of the cumulative dense function, the continuous form, I find the derivative, I will get to the PDF. Now, my question is this. For discrete random variable, how can I define this formula? What is fx? The differential equation, the differentiation in continuous time, what is its equivalent in the discrete time?
Subtraction.
Difference,
Yeah.
subtraction, difference. So this will go into f minus f of x minus 1. So the difference between these two will tell me that what is it? Look, the proof is simple. P fx means that in the discrete form is p of x is equal to x. This, what about the fx? It means p of x is less than lower x minus p of x less than x minus 1. I can write this term as p of x is equal to x plus p of x less than or equal to x minus 1 minus p of x is less than or equal to x minus 1. These terms cancel each other, so they are the same. So, the differential equation turns into difference. This is pretty because I am so sure everyone can subtract numbers. 5 minus 3, 2. And if you can't do it, you have a calculator to do it for you. So this is how I see df, the cumulative dense function, will look like. In general, we start from somewhere till some point and we add all the probabilities. What is the minimum value for CDF? 0. Impossible, so we start from 0. What's the maximum number for CDF? 1. Now, this is a PDF, right? You see, it's going up, down, we have up and downs, increasing, decreasing. But for the CDF, we start from 0, we go to 1. Either each time we are adding something, so we are going up, or we don't add anything, which means we are adding 0. So we are constant. So either we go up or we are constant. It means that CDF is non-decreasing because it's either increasing or it's constant. So we never decrease. With the CDF, you cannot decrease. Imagine if you have done something and when you look at the CDF, when you draw the CDF of your model and you see that at some point it's decreasing, something is wrong. It should not decrease. Why it should not decrease?
Because you're summing up positive values.
Exactly. We are summing up the probability values which are always positive. They can be 0, which means nothing will be changed, but they are, if they are not 0, they are positive. Here for the die that we had, at the beginning, which means the probability of having 0 or less than 0 is 0 because we cannot have it. The probability of having 1 or less than 1, it's less than 1 we don't have it, so 1 is 1 over 6. The probability of having the random variable to be 2 or less means that 1, the probability of having 1 plus the probability of having 2. So it's 1 over 3. As you can see, it is increasing. Here, you can see what is the CDF values in case of a ruling die. The properties of this CDF, as I just mentioned, is it is non-decreasing. At very infinity, impossible we have 0. And at the end, when we are adding all the probabilities, the value is 1. And if you have a mathematical background, you definitely know that this CDF function is always right continuous. We don't care about what is the definition of right continuous. It doesn't bring us anything new regarding the pattern recognition. Now, these density functions have also more different types, which we will talk about them on the next session, which is next Tuesday. Do you have any question? So remember, you have to submit a proposal. You have to send me an email regarding to your project. And if you have no question, this is the end of the lecture for today.